So this one here to me looks kind of like a fun one. So how would I approach it? I would probably just play with it, as dirty as that sounds. So let's just see if we can figure out what's going on here. So we have x, 2y, and then 2z minus 1 are consecutive integers. So let's just say 2, 3, and 4. So what does x equal in this case? X is going to obviously be 2, y is going to be 1.5, and then what is that? Did I say z? Whoops. That's stupid. Oh, you stupid man. There we go. 2z minus 1. So 2z has to equal 5. So z would be 2.5. Which one is bigger? The bigger one is z. Okay, let's see if we can create another situation. How about -2, -3, and -4? And we have x, 2y, and then 2z minus 1. Let's see what happens. So x is going to be -2, y is going to be -1.5. And then we need this to equal -3, which means, why do I keep saying zz? Which means 2z is going to equal -1.5, which in this case they're equal, which is c. This case z is bigger, which is b, and now they're different, so it's d. So what I would do is just play with it. There you go. Now, in quantitative comparison, don't forget you have to test multiple cases, because if you don't, you're going to run into issues where, you know, for example, you find one successful case like I did with the first one. So typically you want to test, you know, something negative, something fraction-y, something exponent-y, something zero-y, something positive-y, something integer, not integer, things like that. And then you're trying to find two situations that conflict with each other, and if they do, you choose D. Okay. Now, one thing we do need to check before moving on to the next problem is, you know, consecutive integers are typically written, you know, from small to big, but this one's written actually big to small. Notice they never say that these have to be in order. They never say that x, 2y, you know, x is less than 2y or 2y is less than 2z minus 1. They never say that. So what we can do is we can say, okay, -4, -3, and -2. Let's just kind of see what happens here. So we have x, we have a 2y, and we have a 2z minus 1. Okay, I wrote it correctly this time. So x is -4, y is going to be -1.5, and then here I need, let's see, I need z to equal negative, I need 2z to equal -1, which means z is going to equal -0.5. So in this case, that is bigger. So I think the answer is D, because they don't say that it has to be in this order. Let's try another one. So -1, 0, 1. Let's see what happens here. X, 2y, and then 2z minus 1. So that's -1. Y is 0. And then that means z needs to be 1. So again, that's bigger. So I could be wrong, but I think they're saying the answer is D, because it doesn't say that x is less than 2y and then 2y is less than 2z minus 1. I think that's what's going on here.